different solutions. And you can see all of them here. But today we are going to highlight 6 of those challenges. So first of all, Joe Martin from Dublin City Council will guide us through the HGV permit checker. This is an app which helps citizens check if heavy goods vehicles are permitted to enter the city limits. Secondly, she will talk about Rate My Service, an app which helps citizens choose public services. After Joe, we have James Arnold from Glasgow City Council, who will talk about data for organizational change. These are apps to mobilize citizens to increase inclusion. My colleague, Dries Lutz, will guide us through the wastewater tracing algorithm, which traces pollution through the sewer system and surface water. My other colleague, Bram van den Linden, will show us the cleanest air route, which is an app that shows citizens the healthiest route to cycle from A to B. And then finally, Vanda Turksi from Orléans Metropole will show us Discovery of Natural Heritage, an app which gives information on cultural and natural sites. I will now give the floor and the screen to Joe. Joe, you can start your presentation. Thank you.
Good morning, everybody, and thank you for being here for our Be Good session this morning. So the first presentation that I will provide you with on behalf of Dublin City Council is the HGV Permit Checker Challenge. So just a quick overview of what's included in the presentation, and we'll talk about the product, which is a mobile app and back office system containing dashboards and statistics enabled by an API. We'll talk a little bit about our target users, the police in Ireland, our local authority staff and citizens. And then the how is Dublin City Council already manages the system that captures and stores HGV permit data. And the why, which is the HGV management strategy in Dublin. It's a citywide cordon, and we had no way of measuring compliance. So this will be the common theme throughout the presentation. So the HGV management strategy in Dublin was introduced in February 2007. It provides for a restricted cordon for HGV vehicles with 5 axles or greater, to minimise the use of the city streets by HGVs travelling to and from Dublin Port, to minimise the conflict between the service requirements of businesses and the needs of other road users, and then to manage the HGV traffic whenever the Dublin Port Tunnel is closed. So the authorities involved in the HGV management strategy are Dublin City Council, who are the permit issuing authority, and then the police force, who are the only authority that can enforce the cordon and issue fines for non-compliance. And up until now, HGVs had to be stopped on street to check for valid permit. The HGV permit app changes that. So this is just a map of the citywide cordon in Dublin, and it's an operation from 7 AM to 7 PM, 7 days a week. And the HGVs of greater than 5 axles or greater must adhere to this cordon or apply for a transit permit or a load and load permit. They also have designated entry and exit points here in the cordon as well. So the HGV Permit Checker Challenge was to open up public sector information and extract value, to demonstrate to citizens how data can be an asset used to solve challenges, and to encourage SMEs to provide an innovative, cost-effective solution with transnational elements. And we also wanted to create citizen engagement and awareness regarding the HGV management strategy in Dublin. So the business need, the big why question, what is the problem that needs to be solved? Well, our challenge was mainly focused on the HGV management strategy compliance. Previously, citizens and enforcement authorities had no mechanism to check on street if a HGV was in compliance with the strategy. And then the business requirement from our side was to create a visualization of existing compliance and create awareness of compliance for future decision making, which I suppose was how the original concept came into being. Dublin City Council agreed to the expansion of the HGV management strategy to incorporate handheld technology, which could be used by enforcement agents, local authority staff, citizens, to expand the capacity for detection of non-compliance in order to reduce the number of vehicles entering the cordon without a valid permit. So when we went to tender, this was our envisaged solution, to have a mobile application and a back office application where we could have some dashboards and produce reports that could then be easily exported into different formats. So from prototype to product, there were several iterations, and these iterations had to include exposure to risk, incorporate GDPR compliance, two-factor authentication, revision of opening up our data strategy, where we initially had an open API for anybody to use, and then we had to restrict that to a native API for security reasons. Also, just to mention that the app, the final product was developed by an Irish company called Tech Enable, and this is what our final product looked like. So we have a public and private user interface on the mobile app, which communicates here with a storage procedure in a database called the Native API. This also communicates with the HGV management infringement system database, and we can publish then obviously that information back to the back office user of the system. So just give you a quick walkthrough of the app. We have our splash screen here. This is quite intuitive. It gives information to users of how many axles should be on the truck that they're reporting. It gives some information about the cordon that's in place. They can input a registration here, drop a pin and pick the place where they've seen it within the cordon, and then they can check for a permit, and in real time they will be notified if the truck actually has a valid permit or if it's actually an infringement. But all queries that come through the app are reported to the back office dashboard. So we have oversight of everything that comes through the app that's reported by citizens. And this is our back office, I suppose, landing page when you log into the back office portal. And here you can see all of the records that are entered by citizens. We can also see the little comments here that when we hover over them, they usually expand, and we can see what comments the citizen has had. We have a number of reporting functionalities and heat map functionality, which I'll get to in a moment. This is just one of the easy query reporting tools that's built in. And we can pick any kind of report that we want and export it into different formats, or can actually be incorporated into another business intelligence application like Tableau. So this was the heat map, I suppose, at the beginning of our journey, when we didn't really know much information about the HGVs that were traveling through the city and their location. And this was like the day that our application went live. So this is one or two reports here where you can kind of see the green here in the picture, that sightings were reported. And when we launched on to the citizens on July 2019. We had a national and citywide publicity campaign. It was really critical how we pitched the app and the campaign for citizen uptake, because we really wanted people to get involved, and obviously haulage companies, and we wanted really to see that it was contributing to the well-being and a positive impact in the city. So this was just some of the coverage that we actually received during the campaign. We made some of the national broadsheets. We also had a spot on our national news on TV. So it actually gained a lot of attention when we did go live. And since then, we've been able to build up a much greater and enriched picture of the intelligence about HGVs in the city. And this is our heat map now, where we can see here obviously the red and the orange is the greater kind of activity, and the sightings from the citizens in these areas. The impact of the HGV permit checker system has seen an increase in permits issued by approximately 35%. So overall, it has been positive, and it's had a positive impact for Dublin City Council in the city, and also for citizens. So that concludes the HGV presentation. If you would like to know any more information, my email address is on the slide, so please do not hesitate to contact me. And thank you.
I don't see any questions in the chat, so I think we can go to the next presentation, which is also done by Joe. So over to Joe again.
So as part of the BGov project, as Kathleen explained, we had 11 challenges, and Rate My Service was the second challenge that Dublin City Council undertook as part of the BGov project. So just a quick overview of what's going to be included in the presentation, which is a detailed look at the product, which is a mobile app, a back office portal containing dashboard data analytics enabled by an open API that is managed by our National Transportation Authority. And they'll also provide information on the data that answers the how question, so the real-time passenger information, and then the crowdsourced feedback from public transport passengers. So why Rate My Service? Just to put some context on it, there is currently no way for public transport users to engage with transport providers that allows the users to provide feedback on the procurement of their stop, while at the same time allowing them to choose the best performing stop in their area. Such a system would empower users to provide feedback on the quality of the service that they're receiving, with the hope of improving the overall level of service of that particular mode of transport. So we would hope that this would benefit public transport users and public transport providers, and that would lead to an engaged public, giving the customer voice, and an improved performance of public transport through informal continuous improvement processes in public transport services. So Rate My Service is a fully hosted cloud-based solution, which was developed by Compass Informatics. This is just a simplified picture of the system architecture, where we have a mobile app and a back office private portal displaying data analytics, which both integrate with the existing real-time passenger information REST service API that's available in Ireland. Yeah, the new element is that, I suppose, it's never been captured and is also classified as open data, is the crowdsourced open data from public transport passengers that's fed into the app. So again, a quick walkthrough of the app and functionality. So this, the first one here, the app opens and presents the users with a map-based view of all bus stops, tram stops, train stations in their area. Users also have the option to toggle between the service providers for added convenience. So these are the different public transport providers that are available in Ireland. When a user clicks into their chosen stop, so here above, stop 1344, they're presented with all routes that service that stop and an option to watch or rate the stop or route in real time. And then you probably can't see the last one here because I think there's a problem with the WebEx application. But here, when the Rate Me button is selected, the app presents the user with some predetermined data about the stop and route. So obviously that's the detail that's captured with the rating that's pushed to the back office portal. So as the user scrolls down through the app and past the predetermined data, you have the option to choose an emoji representing their experience and can select a category with an option to add a comment. Users also have the option to toggle between service providers. Oh, that's the same. Sorry, there's just noticed an error on some of these slides, so apologies for that. So just here in this, this is the wrong bubble box for this screenshot. So here we have the list of categories that the user can give feedback about, and these categories can actually be changed in real time and pushed back out to the app if necessary, if there was some kind of incident or anything like that in the city. Or for example, the COVID-19, we've been easily able to change categories to incorporate COVID-19 measures. And then this here is just the hamburger menu that is in the app. So it gives some idea of the extra functionality that's available within the app as well. So here we have our overview of the back office portal. It's the home page, and this is where all of the crowdsourced information is pushed to and displayed. This is the section where you can filter to find any specific results you would like from a time period, a to and from date, category, operator, stop or route. A closer look at the homepage reveals that there are a number of dashboards here that are hidden, which can be expanded. One example here is shown where the ratings data just displays that the detailed records, such as what device we captured it from, the comment that was input by the user, was it their favorite stop, and also these records, if there was any kind of malicious use of the app, they can be deleted as well. Our next dashboard gives you a quick overview of the number of ratings against a particular rating value. Here, feedbacks per rating, and then the ratings over time gives you a quick overview of the ratings, but now at a scale for proportion. And this scale can be altered by simply dragging along the horizontal or vertical edges to give you a different field of view. And then here our word cloud shows the most used words from the comments sent in, with the number of times used in the time period selected in the filters above. Another dashboard that we have is just a little quick 4-graph display where there's different data about the top operators, stop, routes, categories by average ratings, again based on selected filters. And then this is just a detailed view of the individual ratings data record. So when we come out of the overview screen, we can go into the map view, and the map view gives us a dashboard, which is a visual representation of the locations of ratings, and it's possible to zoom in and out on clusters for a more detailed view as well. We thought that it would be good also to capture some user analytics and display them, I suppose, for future improvements and iterations of the apps and the user experience. So we also have a dashboard in here that captures and displays user analytics. So this here is just the device interaction and ratings. We also have a graph that shows a more detailed look at the interaction inside the app by the users. As an example, you can see how many times the favorite function has been used. And I suppose, you know, it would be useful to know what's being used and what screens that we can remove for future iterations of the app. And then the last dashboard is the hourly rating breakdown graph, and that shows not only what day, what hour, but the number of ratings and the average rating score at that time. So the journey so far for a challenge, it was April 2019, our tender was published. August 2019 was our project kickoff. We had our roadshow and prototype developed in November 2019. And then in April, May 2020, our plan was to deploy to a live public audience, but this wasn't possible. So we released to a focus group. And the reason why it wasn't possible, I suppose, is due to COVID-19 impact. So we've had to issue a notice to say that our health service executive advice on general travel and public transportation was restricted, and that we've postponed the release. So we will expand the focus group and gather as much, I suppose, information and test scenarios and take things from there, I suppose, in the next couple of months. As part of the BGO project, we will have a work package capitalisation, which commences on October 2020, finishes in April 2022. And DCC are currently working on a release strategy for Rate My Service in some aspect, and this is an evolving situation. So again, thank you very much for listening, and if you have any queries or questions, I'm happy to take them.
Yes, we have a few questions in chat, if you can answer them. The first one is, why does the City Council develop an application like this? Are there no commercial parties interested in this data? This would be the first question.
Yeah, so again, I suppose the Dublin City Council saw an opportunity here that we had the availability of the open API, and we also seen the need that there was no such application existing in the market that allowed users to provide feedback while consuming real-time passenger information. So I suppose that was the reason behind it, and obviously the Be Good project, I suppose, brought that opportunity to fruition. If you could just repeat the second part of the question.
If there are no commercial parties who would be interested in this data.
Well, that's something I suppose that we had planned to look into, and we will explore. But we are open to, I suppose, exploring those options. But at the moment, we haven't engaged with any commercial parties.
Okay, thank you. And then the next question is, how do you deal with protection of personal data, of crowdsourced data?
Sure, yeah. So we actually, because we built the HGV app first, we had learned all about GDPR, and we actually built in privacy by design with the crowdsourced application. So all of the data is anonymized completely. We don't collect the MAC address of the phone. There's no IP address. There's no connection of the end user whatsoever. So that was built in by design. And we've carried out obviously data privacy impact assessments and different things. And yeah, there's no privacy concerns whatsoever.
Mm-hmm. Thank you. And there was the third question. Maybe you have already answered this, but still the question is, was this application specifically developed for COVID-19? Because you mentioned one part related to COVID-19.
No, it wasn't related specifically. It wasn't developed specifically for COVID-19. The main reason it was developed was to provide public transport passengers with a feedback mechanism about the service that they're receiving from public transport providers. And I suppose I just put in COVID-19 there on the screenshots as, I suppose, an example of how we can change in real time and adapt the app to current circumstances. So, for example, if I was returning to work now this morning and I had to take a public bus, I would be concerned that social distancing is being adhered to, that there's correct signage, stuff like that. So that's why I just incorporated those points into the screenshot, I suppose, for illustration purposes.
Thank you very much. So those were the questions.
Okay, thank you.
Thank you.
Thank you, Joe. I think we can now move over to James. I will share the screen because there are some technical problems, but James will do all the talking. So.
Okay, thank you, Kathleen. First of all, can I just check? Yeah. No. Okay. Hope everyone can hear me okay. Is that fine? Yes. Everyone can hear me, yeah? Okay, thank you, Kathleen. Thank you for giving me this opportunity to talk to you about Glasgow City Council's experience in working with Be Good. And I wanted to take the opportunity to show how the solution which we're developing with our partner company, MyDex, has been rooted in how we analyze and look at issues around social deprivation and social isolation, and how we're using this app to enhance what we already use in terms of our geospatial data, in terms of ways in which we can use this information to direct our interventions, to deal with public policy interventions, to deal with social inclusion. Next slide, please. Next slide.
I'm having some difficulties.
Okay, thank you. Right. One of the main issues which we use in spatial data our Scottish Government initiative based on data zones. For the last 15 years, the Scottish Government has been producing data, a spatial data set, which covers information on 6,900 areas in Glasgow, in Scotland, 746 of them being in Glasgow. This is a data set which covers demographic data, information on health, the business base, data zones, generally have a population of around about 800 people. Next slide, please. The main use which we have of this in Glasgow is the Scottish Index of Multiple Deprivation. We use that as a way to target our resources and target our programs towards people who are in greatest need, people in disadvantage. The weighting of the index favours issues like income and employment, but it's also been held 6 times since 2004. So we've got a decent data set on how the city is dealing with deprivation, how much deprivation is a problem with the city, but also how it's changed over time. The convention has been that the bottom 15% data zones, when they're ranked, are as a signifier of deprivation. The data can be mapped, and in the following slides, they show the areas of Glasgow which are disadvantaged according to this national indicator. So, first slide, please. Next slide. These are the areas of Glasgow which were deprived in the 2004 version of the Scottish Index of Multiple Deprivation. Next slide, please. These are the areas in 2006. Next slide. 2009. Next slide, please. 2012. Next slide. 2016. Next slide. 2020. Purpose of these slides, it may be difficult to pick up, but it is an indicator there's a considerable amount of urban change going on in a city. If we're focusing on deprivation issues, a number of these areas have moved from being deprived, being disadvantaged. They've changed due to any number of reasons: demographic change, housing, new build housing, housing demolition, those kind of things. But it's indicative that our spatial data sets are able to tell us which areas in Glasgow have got areas of disadvantage which have been deprived. It'll tell us a little bit more about who these people might be. You can pick that up from demographic data in terms of the age groups of the population. So we're able to say what proportion of, say, the 0 to 15 age group lives in a deprived area. We know that's been decreasing. What proportion of the elderly population lives in a deprived area? We know that's been stable. But the pattern has been some areas move out of deprivation, then move back into deprivation. Some areas are able to have a more stable movement pattern. It's indicative that there's a degree of urban change going on in the city, which we need to be on top of if we're to try and understand what's happening with services and the conditions of life and people in the city. Next slide, please. We also know that there are disadvantages and differences between the city and the suburbs in this. The following maps use quintiles. The least disadvantaged areas are in red, and the most disadvantaged areas are in green. Next slide, please. So this is a map of Glasgow, which shows red areas are the least deprived areas. So it's merging from the city council, from the city centre, moving out northwest, which is into the area where the higher education institutions are and some of the more expensive housing are in Glasgow. Areas in dark green are the most deprived areas. So first of all, you can see that even in 2020, there's still quite a large amount of areas in Glasgow which are in the most deprived category. We can move on to the next slide. This shows how areas outside the city have also got some of the more least deprived areas in Scotland. The area in black is the city council boundary. The areas which are coloured are effectively the built-up area in Glasgow. We know a lot of areas, people who maybe work in the city don't actually live in Glasgow. We've got a big commuting set of patterns which go on. So my point here is to show that over time, and Glasgow is an exception in this. We know a lot of people in commute from outside areas, and we know, as this map shows, a lot of those areas are some of the least deprived areas in Scotland. So we know there's issues that people living in the city don't necessarily get access to jobs, and that gives us something to tell us about what we need to do in terms of the programs which we put in place to try and deal with these issues. So, next slide, please. So we can use these data zones, this data zone approach, to show urban change and differences between areas. And combining deprivation data and demographic data, we can identify the drivers of these changes. As I've said, we get a good impression of where areas of disadvantage are within the city and who they might involve in terms of the age profile of areas. But we need to convert this information into something practical. What can we as a council do to best use our resources to deal with these issues of disadvantage? And this is why we've been working with our company, MyDex, to build up a platform to deal with issues around citizen dialogue. This is the main reason why we got involved in the Be Good project. So next slide, please. Our first task was to identify a challenge which we built initially around public transport issues and social isolation. We realized that the solution which we were getting was much broader use and of much broader eligibility and applicability than just around public transport. Yeah. Be Good allowed us to move into areas around individual procurement and working with SMEs in a different way. Next slide, please. Our first idea was to do this identifying a challenge. When we started with Be Good, we didn't really have any idea of what we were trying to do with this. We agreed participation, but not around a particular theme. But we know through the data which you've had, the geospatial data which I covered, you have very clear boundaries within the city. And we felt that our challenge was going to be, how can we find a way of communicating with people to try and deal with these issues around connecting people and place. The next slide, please. Our route went through innovative procurement. We used the Scottish Government CivTech institution to find a way to put up our challenge, which was centred initially around public transport, and take this out to a group of chosen SMEs, 9 in total. And we worked with 3 of them to develop up prototypes, and we eventually identified our partner SME on this. The council doesn't normally work this way. This is an absolute one-off in terms of the way the council generally works. This kind of coming up with a challenge and then looking for ideas is a complete inverse to how the council normally works. They're very tightly defined around, this is what we want, tell us what you can get from it. So this way of working with an SME to develop a solution is very new to the council, and it's been a real challenge to the way in which we do this. Next slide, please. So our basic idea is around working with our SME MyDex. Their idea is to produce this include platform, so a way in which people can identify what it is that they're looking for in their particular area and to match that up with what council services can provide. It relies on continual dialogue. It's a way in which we get people to dialogue with the council and say, these are the kind of services that we're looking for, as opposed to the council saying, here's a set menu of activities which we do, tell us which bits that you want, and we'll do that for you. We're still working on developing up a prototype on this. We've also had to cope with COVID-19, just come at exactly the wrong time in terms of the way the project has been evolving. It's got in the way of all our community engagement tasks. But I want to specify now the kind of areas of work which we're covering. Next slide, please. We're working on 2 user cases, educational maintenance allowances and childcare support for 2-year-olds. These are both programs which are targeted for people in need. we also know that these programs are also known to be underused. So we have this paradox. We have these programs targeted towards people in greatest need, but we also know that these are programs where uptake is known to be low. Educational maintenance allowances are ways in which people can get some kind of support to stay in further education and in some cases into higher education. And it's targeted to people in those 15% areas, those areas which were shaded in the map before. You know there's issues in which people don't complete their education because they have either affordability issues or aspirational issues. Educational maintenance allowances are there to try and help people with some of those affordability problems. It's a Scottish Government scheme targeted in areas which Glasgow's got many of them, and we also know the potential uptake is low. Childcare support is also there for 2-year-olds. We also know that uptake is low. Maybe that's down to cultural reasons. Maybe people feel that 2-year-olds too young to go into nurseries. But nevertheless, we feel it's a big program which can be used to support people who want to move into employment while also raise a family. Still working on how we can get these areas around. But it's meant that we've had a way in which we are trying to deal with these programs with the people most using them. Next slide, please. So we've had challenges around the citizen dialogue in this. We had citizen engagement scheduled for 2020 this year. We've still got a commitment to do this, but the idea would be that this Include platform would be targeted in certain areas, certain community hubs, areas which are based within some of these areas of deprivation and disadvantage, where we can build up a dialogue with the service providers and also people in contact with local people and find ways in which we can bring our services towards people in those areas of need. Just having to work remotely during lockdown, it's not been easy, but we're still managing ways of maintaining contact with people within this. So next slide, please. The idea would be that using our geospatial data through the Scottish Index of Deprivation and demographics, we can identify areas which we need to target within them and use the platform as a way of identifying suitable responses. The idea about this is to use the Include platform to create a dialogue. People are looking for these kind of services, what are able to do in terms of responding to that. Part of the problem in terms of public policy, people who've been working in this field maybe know, you might identify a problem in year 1. It takes you to year 2 before you develop up a solution. In year 3 and 4, you're actually able to put that program into practice and to know exactly how to run this program properly and what the best ways of getting your responses are. That's maybe 4 or 5 years after you identified that problem to start with. And by that time, the problem may well be quite different to what you thought it was. So by the time we're up and running to create this program to deal with these issues, the problem may well have moved on. Unless we have this dialogue with citizens as to what they're looking for in these particular areas, we don't know what we're best able to deal with them. For example, in Glasgow, youth unemployment used to be a major problem. So we developed up a program of youth apprenticeship schemes, and in some cases, wage support schemes to try and get young people into employment. We now know it's not a shortage of jobs that's the problem, it's the quality of the job, whether it's a 0-hour contract, the kind of training which is offered in that. It's not just the quantity of jobs that's now the problem, it's the quality of those jobs. And our programs need to be able to be aware of making that change. Quite often they're not picking that up because they don't have this way of dialoguing with people. So that's really the way and why, the reasons why we're developing up this solution. We're linking it in with the geospatial data, which tells us issues around where problems are in Glasgow and who might be involved in these areas. Our Include platform is going to give us answers to some of what are the best kind of interventions we can make? How are they best going to be designed? Why do we want to do them in this particular way? when is the best way to put them into practice. We're trying to deal with this much tightly more with the public programs which we as a council operate, which our council partners also operate. Next slide, please. Still an evolving situation. BGood has managed to enable us to develop this work. It's taken longer than we thought it was going to do. But one of the other aspects of BGood is that it's provided us to develop a whole lot of supportive activity. Design innovation approach, which we've pioneered on this, develop an online toolkit to work with the design solution. We set up new kinds of ward dashboards to try and identify new types of information, mainly about service provision and ongoing participation and production of work. Our work around transnational work has made us much more reflective of what kind of interventions we're doing. So, final slide now, please. So we're still working to turn this concept into a reality. Timing has been unfortunate. COVID-19 has made a lot of our work much more difficult. But what we're finding is that we're developing new information on geospatial concepts, on service demand, local provision, how that varies between areas. BGood has facilitated this and has enabled us to get new perspectives on our kind of work. The future will be these new ways of working with challenges, with SMEs. The BGood experience has been an ideal opportunity for us to shape our response and to gear us up to working our way in the future. So that really is all I want to talk about at the moment. Thank you very much for the opportunity, for giving us the opportunity to speak to you about that this morning. And I'll be interested to take any questions that you have for me. Thank you.
And we have a question in chat.
Okay.
The question is it possible to combine your application with social media data? And then it continues for communication with your target, for example, for communication with your target groups.
Yes. I think the idea is creating our own form of social media. The include platform is a way for which people to identify what services they're looking for, the service providers to tell them these are the services which we're providing, and to make that link. Rather than people having to find out through newspaper information or posters or something, the idea would be for this information to be directed towards their mobile phone, their mobile app. The big question there is, what do we do with people who don't have mobile phones and mobile apps? So we have a digital inclusion strategy in Glasgow based around public libraries. We still have them in Glasgow, and this isn't linked to individual products, individual digital products. It's linked to a digital account. And people can access those digital accounts through public libraries, through PCs and public libraries. It's possible for people who don't have a social media presence to still be able to use this. This is the reason why we're linking this through some of the community hubs in Glasgow, because they're going to be our way to connect with these people. The idea of this is that we connect with people who don't normally speak to the council, don't normally have a dialogue with the council, because they don't think the council provides services which they think the council actually does. So I think, to answer your question, I think we're creating a new form of social media which goes beyond what's normally out there and which we can use to connect with people who don't see social media or digital things as a way for which they might find out services. The second question, can you just repeat the second question, please?
Yeah, it was connected. The second question was connected to the first one. So how, especially for the communication of your target groups?
It's been rolled out through our community engagement strategy, which, as I said, we've had issues about dealing with COVID-19. And I think this means we're using our existing networks which are already existing within local communities, slightly based around a hub, a community hub, or particular organisations. And to build, my initial idea was to have a lot of local meetings with those people to go and say, this is what we're trying to do. Can we use this, use your networks to engage with people through this, as well as using our existing social media connections through some of our existing apps. But what we're really trying to do is to try and engage with people who don't engage with the council to start with. And the way we might do that is by going to specific organisations in areas of disadvantage and going to say, can we talk to you about what we're trying to do with this? Can we find you ways of using your contacts to try and bring them in and engage with us through this particular technology, this particular technique? And in that way, we're building up completely different dialogue. Rather than those we already speak to, this is how the council might design its services based around people that we don't have an existing network with, have an existing engagement with. And this is most true in terms of a lot of the ethnic minority groups and some of the more diverse groups. They don't normally have an engagement with the council for a particular, very much a specific reason. So don't see the council as being something to have a dialogue with. So this is going to be the way in which we're able to engage with these diverse groups, which are becoming a bigger part of Gaza's population. So I think the strategy would be building with people who are trusted in their organisation, and then make our interventions through them, rather than just do a blanket approach and to see who comes back. That answers.
Okay, thank you very much, James, for this very nice presentation.
Thank you. Okay.
I think we can now move to Dries, who will show us the wastewater tracing algorithm. Dries, you can share your screen. Yeah.
Okay, so I will be presenting to you the wastewater tracing challenge, which is set out by Flanders Environment Agency as part of the Be Good project. Our goal with this wastewater tracing challenge was the development of a tracing algorithm, which is able to trace wastewater through the sewer system into the surface water system. At Flanders Environment Agency, we want to use this tracing algorithm to support our processes surrounding sewer planning, surrounding sewer policy advice, and sewer incident management. I'm going to start with a short, quick demo showcasing one of those use cases. So at Flanders Environment Agency, we have water researchers who specialize in researching or finding sources of pollution and taking actions to mitigate all kinds of pollution. So for example, this use case is based on a real life event. One of our water researchers has found pollution in a river and wants to know where this pollution could possibly be coming from. So then they can use our tracing algorithm to do an upstream tracing on the surface water system, and also ask our tracing algorithm to connect back through the sewer system. And by doing this tracing, they can identify locations where the sewer system connects to the surface water system and quickly get an ID which locations they need to inspect for problems that could lead to a spill. For example, in this use case, they found that at one of the locations within one of the overflow structures of the sewer system, an internal wall collapsed, and this internal wall in normal situations prevented raw sewage from flowing into the surface water system and diverted this sewage to the treatment plant. Okay, so within the Flanders Environment Agency, the development of the tracing algorithm is not only part of the Be Good project, but it's also part of the sewer inventory project. The sewer inventory project has the goal to combine all Flemish sewer data into one database And this database is set up to support sewer planning and policy advice on the sewer system. This database is accessible through a web application, which provides a tracing functionality, which is developed within the BGood project. And this tracing functionality is called the graph tracing engine. So for tracing within the sewer inventory, we use two datasets. And the first dataset we use is the surface water dataset. This is a dataset which is owned and managed by Flanders Environment Agency. And this dataset is also harmonized to the Inspire hydrography network data model. And the second dataset on which we perform tracing using the sewer inventory is the sewer inventory sewer dataset. This dataset needs a bit more of an explanation. This dataset is not owned by Flanders Environment Agency. It is owned by the local sewer managers in Flanders. So the dataset is kept in the systems of the sewer managers in different formats and in different data models, which means that the dataset at its core is a very heterogeneous dataset. And this is a bit of a problem because for the operations we want to perform on the sewer database and for the tracing operations, we need a harmonized and connected network. So to get to a traceable network, at Flanders Environment Agency, we undertook several actions. The first action was to sit together with the sewer managers and agree upon a standard data model that they could use to deliver data to us. For this data model, we looked at which data models were already in use in the sector, and we found that they already used an extension to the Inspire Utility and Governmental Services data model. This extension is called EMKL and is developed by Information Flanders and is within Flanders mostly used to exchange data on underground utilities to prevent dig damage to those underground utilities. And so we took this EMKL model and extended it with sewer-specific information and created our own AquaStrength 2.0 model. When sewer managers deliver data to the Flanders Environment Agency in this AquaStrength 2.0 model, we run validations on their data, and we also enrich their data with planning information which is available at Flanders Environment Agency. This combined data set is then loaded in the graph tracing engine, which itself also contributes to making the network traceable by being designed to be robust enough to be able to load, to be able to deal with imperfections in the data, such as loops. We also designed our graph tracing engine or tracing algorithm to be a very flexible tool because we needed a tool to be able to load both the surface water data sets and the sewer data set at the same time. And both those data sets have a distinct and different network structure. And we also needed our tool to be able to make the connections between both the sewer system and the surface water system at the moment when the data is loaded into the tool. So the graph tracing engine is able to connect up multiple networks, both in a logical and in a geographical way. The graph tracing engine is also able to perform filter operations on the tracing results and is able to aggregate certain attributes along the tracing route. And the graph tracing engine allows for both upstream and downstream tracing. Another important aspect that we needed the graph tracing engine to be able to do was to perform tracings on a very large and detailed data set. Our sewer data set is the size of Flanders and goes into detail to individual sewer pipes. We also wanted our graph tracing engine to provide additional functionality, which is not strictly related to tracing on networks. We wanted our graph tracing engine to be able to detect zones along the tracing routes, which could be considered to be at risk for pollution, such as nature reserves. And we also developed our graph tracing engine to be future-proof for future expansions we maybe want to do to the sewer inventory. For the future, we may want to load data from our neighboring countries in the sewer database, and we wanted our graph tracing engine to allow for cross-border tracing. And for our tool to allow this, we set out that our tool needed to be able to load Inspire data. So I will quickly go over the architecture of the graph tracing engine. The graph tracing engine is designed to be a microservice, so it actually works independently of the Flanders Environment Agency infrastructure. You can take it out of this infrastructure and plug it in your own infrastructure. The graph tracing engine consists of 3 parts. The first part is the graph preprocessor, which is responsible for loading the network datasets into the graph tracing engine. This graph preprocessor is designed such that it keeps requirements on the data model for the network data you want to load into graph tracing engine are kept as low as possible. And the graph preprocessor is able to load data from all kinds of data sources, such as shapefile, Postgres database, GeoPackage, GML, Access databases, and so on. This graph preprocessor combines all the networks that are loaded into the tool in one connected network that is used in the second element of the graph tracing engine, the tracing core, for the tracing operations. And the third element of the graph tracing engine is the REST service, through which external applications can contact the graph tracing engine for tracing requests. And these external applications have a high degree of customization they can do in those tracing requests. They can define on which of the preloaded networks they want their tracing to be performed. And they also can define their own custom filters on the tracing request. So I also want to quickly discuss what was the impact of the Be Good project on the development of the graph tracing engine. So within the Be Good project, an important theme is that every application we develop within the Be Good project, that they can be transnationally applied, can be used in other countries. And for the graph tracing engine, we looked at this problem mostly as a data requirements problem. We wanted our graph tracing engine to be able to load and use other data sets and other data sources than the ones that are in use at the Flanders Environment Agency. And to give our developers a clear goal to reach, we set a benchmark. For this benchmark, we used the Inspire data model. We wanted our tool to at least be able to load data that is conform the Inspire generic network model. Within the Be Good project, we also got the opportunity to perform a proof of concept of the transnationality of our application. We were able to use data provided by the Delfland Water Authority in the Be Good project to load data from the Netherlands in our graph tracing engine and to do successful tracings on this data from the Netherlands. The Be Good project also incentivized us to design the tool in a more generic, configurable, and standardized way than we would normally have done if it would just have been a tool for use within the Flanders Environment Agency. And we were also incentivized to release the code of the project on GitHub under an open source license. During the development of our graph tracing engine, our SME who did the actual development also produced a business potentials report. And within this report, they identified several use cases for which the graph tracing engine could be used, and linked some of those use cases also to Inspire teams that could provide data that could be used in those use cases. For example, the utility and governmentals team from Inspire will be able not only to deliver data that can be used for our applications at Flanders Environment Agency, but also for other utility network tracing applications. The hydrography team from Inspire is a team that could provide data that could be useful for a lot of use cases for the graph tracing engine. Some of these use cases are the tracing of pollution incidents, tracing to analyze the spread of invasive species, and tracing of sediment transport through the sewer system and the surface system. This last use case is a use case we will be further exploring at Flanders Environment Agency and Database Sub, so Flanders, within the extension to the Be Good project, Be Good Capitalization. And then the third Inspire team from which data could be used for use cases with the graph tracing engine is the transport networks teams. And these use cases are mostly limited to non-route issues related to traffic. I need to add that for some of the above mentioned use cases, to get full benefit from the graph tracing engine, you may need to make sure changes to the algorithm compared to how the algorithm is available on GitHub. So the last thing I want to do is point you to some more locations where you can find more technical information about the presentation. So at the Phosphor Belgium conference last year, our SME presented a more technical presentation about the graph tracing engine, and this presentation is available online on their conference website. And you can also find more technical information on GitHub, where you can also download the code of the project. This code comes with test data and a Spring configuration that allows you to quickly set up your own testing instance of the graph tracing engine, independent of the need for setting up servers or for connecting up your own databases to the graph tracing engine. Okay, I want to thank you for your attention. I'm also going to mention that we have made a promotional video explaining in short what I've presented in Bonn now in this presentation about the graph tracing engine and the wastewater tracing challenge. And this video, you can view it on YouTube. So are there questions? Okay, I don't see any questions. So I think it's time for the next speaker.
Yeah, I think everything was very clear, Dries. Thank you. And we will now go to Bram, who will show us the cleanest route to cycle from A to B. Bram, you can share your screen now. Yuri, have you made Bram presenter?
Yeah, Kathleen, it should be presenter and unmuted, but it keeps on muting. Okay, so Bram is not presenter. I gotta try again. Seems we lost Bram, so he's probably reconnecting for the moment. So he might have had some issues with audio. So we'll have to be patient for a couple of seconds.
It seems we have lost Bram from this session. Do you see the same, Yuri?
Yeah, so Bram probably has to reconnect for the moment because he had audio. Sorry, yeah, Bram has lost. We have lost Bram, so he had to reconnect, I guess, because he had audio problems. So I think we can expect him to turn up again in the coming seconds. Let's give him another 10 seconds.
Okay.
Otherwise, Kathleen, I suggest that we continue with Vanda and then come back to Bram in the end. So to give him a bit more time to get set up again.
Yeah, okay, that's great. So we will now go to Vanda with her app on natural heritage. I will share the screen for you, Vanda.
Yes, so can you hear me? It's okay?
Yes. Yeah.
Okay. So you can put my presentation on. So hello everybody, and thank you for being here in this online session. I'm Vanda Turci from working for Orléans Métropole. So I'm going to present you our project on the discovery of natural heritage, which is one of the challenges of the Be Good Interreg Northwest Europe project. Next slide, please. So I just wanted to situate you on Orléans Metropole. Orléans Metropole is situated in the heart of France, consists of 22 municipalities, and Orléans Metropole has almost 300,000 inhabitants and more than 30 parks. It is crossed by the river Loire, which is a UNESCO World Heritage Site. So we can say that it's a very exceptional area in terms of nature. Next slide, please. So, despite of the fact that Orléans Metropole has a very rich natural wealth and biodiversity, it hasn't been reached their full potential yet. So many inhabitants and tourists are not aware of this natural wealth. So the challenges and the project goals were for us to the encouragement of the discovery of the area, of the nature and biodiversity of this area in a very original way, and also to make citizens player of the discovery through personalized sensory walks, and to develop an innovative solution which enables these experiences. Next slide, please. So the project was developed with a startup, with an SME coming from Montpellier, INEO, and it started in 2019, May 2019. The methodology was based on design thinking. So it means that the solution was co-constructed in different phases with citizens and the services of Orléans Metropole. So in the first phase, we had observations. We observed the 7 different places in the area of Orléans Metropole. And we observed how people behave in this natural places. And then in the second phase, we made some explorations. So through 30 interviews with citizens about their habits regarding to the nature. In the third phase, in the ideation, we organized several workshops to imagine the future solutions, and in the first phase, so in the co-conception, we selected the most relevant ideas, and we imagined with the citizens the conception of the solution. So which was personalized walks, and they imagined the different kind of personalization and different kind of walks. And then in the last part of the design thinking, in the prototype phase, we tested the mock-up with users to define more clearly the solution. So the results which came out from this design thinking was that people would like to find the places around them, but in a kind of personalized way. So like depending on their wishes. They would like to get more information about these places, and also have a fun experience during their walks. What were the constraints? It was that there are already many existing tools on the area, so websites, apps, and also lots of data, but in a kind of isolated way. So they are not really crossed among them. So the question we asked was, how can we use open data to create and deliver personalized experiences, so through walks, and using already tools which are already used by the people. So next slide, please. So the solution of our challenge is a work generator. So it's an algorithm which is fed by different data sources, data which come from Orléans Metropole, so which we put released data, and also from other data sources. And so our solution for open data is an open data soft. It's an open data platform, and it is collected integrated in a common database with other data sources. And so this database feeds the algorithm and impact the algorithm. And this algorithm can be queried by a chatbot, but we also had the question at the beginning if we are developing a chatbot or a website. But after the tests with end users, it turned out that the chatbot was more interactive, and it was a better solution to query the algorithm. And the advantage of the chatbot is also that it can be integrated in different interfaces. So like on the schema, we can see that it can be, for example, integrate in the existing solution of INEO, so Explorama, or the existing app of tourism app of Orléans Metropole, which is a destination Orléans, or in other interfaces. And then so users can use already the tools which they are already used to apply and use. Next slide, please. So we are integrated lots of spatial data and inspired data. One part is of coming from OpenStreetMap, and then as I mentioned, also coming from data that Orléans Metropole released. And just to give you an example for a green profile, so the algorithm is impacted by the different weight of green spaces, green data, and the road data. So, for example, parks have a higher weight than a tree or a fountain. And of course, a pedestrian path has also a higher weight than a secondary or primary roads. Next slide, please. So what does it mean in reality? So that you can, as you can see on the screen, on the left hand side, it's the shortest way to go from A to B. So it's what is used usually by Waze, by Google Map, or when you would like to go from one way to one point from another. And with this algorithm developed by INEO, you can see that the algorithm impacts the shortest way and propose a green way. So it's you can see at the bottom the two different ways that is used by an original and ordinary routing and by the algorithm. Next slide, please. So as I mentioned that the algorithm, so the name of the algorithm is Foxtrot. Foxtrot can be reached by a chatbot, and this chatbot is at the moment it's an ongoing integration into the tourism application of Orléans Metropole, and will be tested during this summer. And but it can be in the future also integrated in the Facebook, for example, of Orléans, or in the official website of Ornean. And as the algorithm uses OpenStreetMap data, and it's an open source algorithm, so it can be replicable. It can be replicated in other areas, which is of course one of the most important criteria of BGood, as it has been already mentioned by my colleagues. So next slide, please. And this solution, it's also a tool for redynamize the area after COVID-19. So people need the contact with the nature at the moment, and the solution, the algorithm, can also promote local ecotourism and can explore new attractions. But as the algorithm is focused on pedestrian and cycle ways, they also help and support the development of soft mobility, which is also one of the most important impact after COVID-19. And so it's not a finished project yet. It's still in evolution, and it will be continue to develop during the capitalization call, which were already mentioned by my colleagues as well. So it's I proposed you and I showed you a green profile, but there are other possibility of other user profiles, like calm way or calm walk or entertaining walk. So there are other data which are already tested on noise data, and which is also part of Inspire data and Inspire Spatial Data. Next slide, please. So in the conclusion, the challenges which Orléans Metropole experienced during this project is the collect of the data from different services, which were at the beginning not around the same table. So we managed to came together and have a common project and open up their data, which at the beginning of the BGood project was not the case. So thanks to BGood project, we started to open up our data, and now we have an open data platform. So the benefit of this project and global way, the BGood project, that at the beginning services were like not really, they didn't have habits to open data, but thanks to this project they created even new databases, and like the inventory of works of Orléans Metropole. And they, of course, one of the benefits is also the creation of this new service by INEO. The difficulties that we met during the project, that, for example, some data sets were done for a professional level, for example, the management of green spaces, and it was not relevant in some way for a wider audience. So then the last slide. So thank you very much for your attention, and I'm happy to answer if you have questions.
Yes, indeed, we have 3 questions in chat. The first one is related to possibility if you can use also the solution of crowd control, for example, to avoid too many people taking the same walk.
So as I mentioned that for the moment it's a very young project. So for a crowd control, we have to see with INEO how can we work on it. but for the moment, it wasn't a question that we talked for the moment.
Yes, thank you. And then the second one is related to functionality as well. So what about accessibility rating for people with disabilities?
Of course, if we have data, and we have data about the, for example, the that kind of not soil, but the ground, and there are, depending on data we have, but we have data on disabilities, and also on parking data. So if it's integrated, the algorithm can be adapted. So it's but it was at the beginning, it was also thought that in different profiles we can imagine that the work is done with in family or with disabled people. So yes, it is considered.
Thank you. And the third question is more related to data sources, and it is the question is why official data, for example, from IGN, is not used instead of OpenStreetMap.
So it's well, it was the so it was the choice of INEO to use one of them data from Orléans Metropole and OpenStreetMap, but as it's also still a project which will so it's in evolution. So we can also check for the future if we can integrate also, of course, data from EGN. But of course, Orléans Metropole has already this data. So it's yes, we have to check with INEO.
Yeah, thank you.
Thank you.
That's all questions.
Thank you.
Thank you, Vanda, for your nice presentation. I think we can now go to Bram.
Yes.
I hope people still have a little patience and stay a bit longer with us, but I will now give the floor to Bram.
Thank you. Yeah, we will try again because the application suddenly crashed when I tried to present. I hope you can all see my screen now. Yes?
Yes, we see it.
Okay, let's start. We aim to provide solutions making your cycling and walking more healthy, more clean, by enabling you to reduce your exposure to air pollution during your commutes. In the Be Good project, we developed a demo application simulating the cleanest air route for various route alternatives, providing you with, if you provide a start point and an end point, for example, your commute from home to work with the bike, you will provide it the cleanest route, along with the shortest route and the fastest route. And what we will do is first we will look to the basics of our research, and Tommy will go more into detail of the demo application, and also list some requirements what it would take to implement the solution we developed across Europe, and also provide some scientifically sound methodologies to do so. An existing review study taking into account many existing studies found that, for example, on roads with a lot of traffic compared to roads with a limited amount of traffic, concentrations for various air pollutants are considerably elevated on roads with a considerable amount of traffic. For example, on average, a 40% higher concentration of black carbon on roads with a high amount of traffic compared to roads with a limited amount of traffic. 26% for particulate matter, smaller than 2.5 micrometer, 70% for ultrafine particles, 102% for volatile organic compounds. And choosing alternative routes where there's a lower amount of traffic can often reduce your exposure to those dangerous air pollutants. And this exposure to air pollution can have adverse effects on our health. For example, on our hearts, on our lungs, on our brains. For example, studies found significant associations between the pollution on our route from home to school and the cognitive development of children. Similarly, there are various studies linking air pollution with the intelligence coefficient, also traffic-related air pollution, implying that the average intelligence coefficient is reduced by air pollution, what on the one hand means there are less super intelligent people, and on the other hand that there are also more people with an intelligence coefficient below a threshold where they can independently function in our society. Similarly, negative effects on our hearts and lungs increases the incidence of heart attacks, or chronic heart diseases, traffic-related air pollution can also increase the incidence of asthma and other lung diseases. And before we go into detail of our application, we'll start with providing the basic knowledge you need to know to understand of our air pollution models we use. It is called the Atmos Street Model and consists of several components. We have the real background concentrations, what are the interpolations of reference measurement stations in Belgium. Then we add land source emissions such as traffic, point source emissions such as factories, also meteo data, because the dispersion of the air pollution can be influenced by those meteo conditions. And taking this all together, you will see we have the 10 on 10 meter RIO EVDM high resolution model. In recent years, we also added an additional component taking into account street configuration effects. And what we tested then is, are those models suitable to use in routing applications to simulate the cleanest air route? And what we see then, if we compare, for example, with the trajectory measurements of black carbon who are conducted on the road, with a bike, then we see that our models, the Atmos Street model, is able to make a distinction between routes with a low level of pollution and a high level of pollution, actually in close to 100% of the cases for most pollutants, certainly for black carbon and nitrogen dioxide. So yes, the models are suitable to use in applications to distinguish between a less polluted route and a more polluted route. However, if you don't look to the absolute concentrations, if you compare the absolute concentrations with the measurements of black carbon conducted really on the road, we see that absolute concentrations are slightly underestimated by the Atmos Street model. So the difference is smaller according to the model compared to the measurements. There are some reasons for that. There can be some inaccuracies in the measurement data. There can be some inaccuracies in the traffic emission data. But one of the main reasons is that despite we have a 10 on 10 meter resolution model, that the receptor points, the closest receptor points to the roads are located 15 meters from the road. This implies that the model actually more simulates near the road concentrations and not really on the road concentrations. And it's an important explanation why the on the road concentrations are underestimated by the models. So what we can conclude from this is, on the one hand, yes, absolutely, the models are able to distinguish between less and more polluted routes and suitable for applications to use them. But if you really want the compare the absolute concentrations, are still work in progress to do because the on the road concentrations are underestimated by the models. Which, and here you see one of the here's illustrated one of the explanations for this. You see, for example, that the concentration of nitrogen dioxide is can be already 1/3 10 meters from the road than really on the road. So yeah. And then we also conducted research into the spatial temporal patterns of air pollution, was also very, very relevant to take into account when developing the final application. Because spatial temporal patterns of air pollution are even more invisible and unknown to active commuters, and both impact absolute concentrations and relative concentration difference between routes. And we don't go into detail in this, but the conclusions we draw from our research is that for the purpose of making the most reliable distinction between less and more polluted routes using the best available high-resolution model data in Belgium, that as long as no real-time chain of the optimal street model is available, static aggregated data on a seasonal hourly level are the most suitable and the most fit for this purpose. And this is because the invisible patterns of spatial temporal air pollution, such as absolute concentration, vary on a daily level, on a monthly level, on a yearly level, on an hourly level, to take those seasonal and daily fluctuations into account. Here do you see an example how the demo application looks like, and those applications can be used by individual citizens to explore if there are less polluted ways to cycle to school or to work or to cycle for fun or recreation, that can reduce their repeated exposure to air pollution when they structurally change their commute to a more clean route. So, and as mentioned before, there is no real-time chain of the high-resolution Admor Street model. So the best option is seasonal hourly maps. But it also implies, for example, that exceptional events such as a car-free Sunday will not be visible in the applications. And yeah, it's important to realize that, because you see on car-free Sundays the concentration of various important pollutants such as black carbon, nitrogen dioxide, ultrafine particles are 50 to 70% lower often compared to unusual Sundays. Beside that, and beside the model specifications itself, it also does matter which calculation methodologies you use to calculate average air pollution concentration over a route. In our research, with the purpose of calculating average concentrations over the distance of a route, we found that calculating the concentration using equidistant points every 5 meters on the route provides reliable results that don't add additional uncertainty. However, it might be tempting for profit-oriented applications or organizations to use simpler calculation methodologies, such as taking the average concentration of street segments. This can make the average concentrations displayed far less reliable, and from a scientific perspective, it's strongly recommended to use, in this case, always the hard right thing to do over the easy wrong thing to do. And to provide you with a concrete example to summarize all elements I said, imagine you cycle daily 13 kilometers from home to work. Based on the applications we presented, you can detect, for example, that we have 3 route alternatives, of which one of them has the lowest concentrations of nitrogen dioxide and other traffic-related air pollutants. So specifically, the application we developed displays nitrogen dioxide, but to a considerable extent, it's also correlated to other traffic-related pollutants. And if as mentioned, you have to choose between, for example, 3 routes, you find one route that is less polluted than the route you know. Then you are able to switch to this route permanently, structurally. This will structurally lower your exposure to those air pollutants. And it's okay to assume your cognitive skills are less impacted by air pollution because of that. It's okay to assume your chances of an air pollution triggered heart attack are lowered because of it. However, the information is not detailed and reliable enough to quantify the reduction in pollution you are exposed to, and to quantify the risks and benefits on your personal health. In another situation where you have only one suitable route to your work from home, or to your school from home, you can conclude it's time to change demand a change as your government to make your cycling to work more healthy. Up to a certain concentration, it is still healthier to cycle despite the pollution levels. But of course, if you can lower your exposure to pollution, you can improve your health. If you see there's only one route you can really use to your work and it's very polluted, you can also use the application to, for example, ask that the measure are taken to reduce the pollution. For example, reduce the amount of cars, or create a cycling lane separated some meters from the road. And to conclude, we put the information provided in this presentation about the cleanest air route in the Be Good project in a European perspective. Many components the Belgian air pollution data and models are based on are already Inspire proof, such as viewable and downloadable, interoperable, open Geospatial consortium services. Metadata are available. There is access to the spatial data sets. But if we specifically look to the Be Good solution of the cleanest air route application and aim for a harmonized rollout of the solution across Europe, there are still some steps to take. For example, some countries have similarly to Belgium high resolution pollution models, but not all have. And even if it is technically possible to combine the data for countries with similar high resolution model data, there are still some requirements. It's important that you realize where you are comparing the same or not. It's the same resolution, the same specifications. For example, even if the same resolution, as mentioned, for the Belgian model, for example, the distance of the crisis receptor points to the roads is 15 meters. That is something that will not be visible in the metadata. So even if you have the same resolution, there can be some precautions you have to consider to ensure you are really comparing the same. And as you mentioned before, however, it's good possible to make a reliable application that can make trustworthy distinctions between routes with more and less traffic-related air pollution, and even good possible that those applications can be extended to the whole geographical, to a large geographical area within Europe. But when we want to quantify concentration difference between routes, calculate exposure in a reliable manner, a lot of efforts are needed. And let's hope that with this presentation, it was clear and useful to inspire you to also deal with these efforts if you are an organization related to air pollution or mobility. Thank you.
We have also 4 questions in chat. Can we briefly go through them?
Yes.
So the first question is this mobile app already live for Android or in Android or iOS app stores? And what is the uptake of this application in Belgium where it is used?
So the application we developed in this part of the Be Good project is a web application. Mm-hmm. So it's just a web link. But in the capitalization project of the Be Good project, so the second part of the project, we will also make a high performance mobile application for a certain area within Europe, probably Belgium. Mm-hmm. And the uptake, in Belgium, we communicated the link through various channels so that people can test the application, also give feedback on what they think should be improved to the application. And also I gave previous presentations on various conferences, and there is uptake from some universities, from the healthcare sector. There's really some uptake in progress in Belgium.
Thank you. You already explained on this slide that we see on screen that how it is possible to apply this application on some other data. So the question here is, can other countries with air quality data integrate their data with this application? Maybe if you can just summarize shortly.
Well, technically that is possible. However, the application we developed in cooperation with Geospatial, it's a small company in the Czech Republic. We already got the routing basics and could implement our air pollution data easily. So they will be able, of course, to to add data from other countries, but also other companies can. We have an open data endpoint, so actually all companies that want can develop applications based on the data. And what is especially important is that we also provide scientifically sound methodologies to how to implement those data. And those recommendations are not only valid in Belgium, but also across Europe.
Thank you. 2 quick questions. Does your application include road surface quality, for example, suitable for different type of bicycles, like racing bikes?
Yes, the demo application contains, beside the air pollution part, also bike friendliness, taking into account the type of road, etc. Yes.
Thank you. And the last question, are the measured data represented in the application along with the modeled data?
No, because the measured data, we have the reference measurement stations, but there are only about 100 points in Belgium, and we have done the on the route measurements conducted with a bike for black carbon, a various route across Belgium, but it doesn't cover the whole of Belgium. It covers only specific cities, and actually our models interpolate for the whole of Belgium air pollution concentrations. The measured data are not represented in the application, but the most important thing to remember is, as mentioned sometimes in the presentation, the models are very good able to make a distinction between less and more polluted routes, but the absolute concentrations simulated by the models for on-the-road concentrations on roads with a lot of traffic are underestimated.
Thank you. That were all questions in the chat.
Okay.
Thank you.
Okay, thank you, Bram. I think we can finish here. We saw 6 of the Be Good challenges today. All the presentations will be available online, and there are links to the Interreg Be Good website where you can have a look at the other challenges also. There's also a brochure available with a bit of explanation on what we did with the 11 challenges. So I thank everybody for listening today. Thank you and goodbye.